This is David Spears, Civil Engineering Instructor at Texas Tech University, talking about CE 2301 statics. This is part two of moment of inertia by double integration, which is, my opinion, the more difficult way to do this, but it surely works. So in this case, we want to find Ix and Iy, moment of inertia about the x and y axis for the shape shown here, which is created by an x-axis boundary, and the function of this curve y is equal to x cubed divided by 4. So in this case, we're going to make the outside part of the double integral, the dx part, integrate with respect to x, last in the two-step process. And we're going to say that Ix, do it first, is equal to the calculus integral of y squared, and we've been calling it y tilde squared dA. Okay, so we're going to write that out as a double integral, and we're going to keep, as I say, on the outside the integral with respect to x, and on the inside we're going to have the integral with respect to y, and it's going to be y squared dA. Well, dA, as we know, can be expressed as a little square of dimensions dy by dx, and so that's what we're going to plug that in there for dA. So that's equal to dA. And as I said, we want to keep the axis for integration on the outside, that's the boundary axis. So on the inside, we want to keep this part and integrate that first. And so we would say the integral of that is the integral of y squared dx, dy, is going to evaluate, the inside part is going to evaluate as y cubed over 3. And now we're going to integrate that with respect to dx. And so that's going to give us our integral Ix is equal to the integral. And once again, we've got a 1 and a 2 for our boundaries on the x-axis, so we're going to integrate from 1 to 2. The integral of y cubed over 3 dx. Well, let's separate the 1/3 out and bring it out here to the outside of the integral. Then I've got the integral of y cubed. Well, y cubed, y is equal to x cubed over 4. That's a given. And we've got to cube that. And all with respect to x, dx. So I can evaluate that as 1 over 3. And then on the inside of the integral, I've got x to the 9th. Evaluate x cubed over 4 cubed is x to the 9th over 64. And so I can bring that 1/64th out, and I get 1 over 3 times 64, integral x to the 9th, which is equal to 1 over 1920, which is 3 times 64 times 10 times x to the 10th power. So I want to evaluate that from 1 to 2. That evaluates as, at x equals 1, a very small number, 0.005208. And on the top, when I integrate with respect, or when evaluate with respect to x equals 2, I get 0.533. And so the net result of that is 0.5328 inches to the 4th power. That's the answer. Now I can evaluate Iy in a very similar manner. Iy is equal to the integral over the area, which is something I forgot up here, of x squared dA. We've been calling it x tilde. So once again, I want to keep the dx, the integral with respect to x, on the outside of the integral and do the y part on the inside. And that's going to be the integral with respect to x times the integral with respect to y of x squared dy dx. So as I say, I'm keeping the inside part like that, and evaluate that first. And so that evaluates to the integral of, with respect to y, of x squared dy. Well, x squared functions as a constant in there, and so that evaluates to x squared y. The integral of dy being y. Therefore, I put that into the middle, or back into the outside integral, and I get that Iy is equal to the integral from 1 to 2 of x squared y dx. Okay, well, y is equal to that thing, x cubed over 4. So this evaluates to 1 to 2 x squared y is equal to x cubed divided by 4. So I can simplify that to be 1/4 x to the 5th power, which I'm going to bring that 1/4 to the outside of x to the 5th, integral of x to the 5th from 1 to 2, which is 1/4 times 6 x to the 6th power from 1 to 2 evaluates as, at 1 it's 0.04166 repeating, at 2 it's equal to 2.666 repeating. Therefore the answer is the subtraction of those, 2.625 inches to the 4th. Okay, so I've got Iy almost 5, or more than 5 times, I guess, bigger than Ix. Why is that? Because this area is a lot further away from the y-axis than it is from the x-axis, so I would expect Iy to be a lot bigger.